assignment. And the next one is from the workbook, so I probably will give you a break, but I probably won't after that. So when you're hearing me say, write down the problem, that'd be a good time to make sure you have that. So as I'm looking at these, because we have a small homework quiz at the end of the class today, and by the way, we do not go to lunch at our normal time today, so at 35, there's no one getting up out of their desk and getting ready to go. We go later because 7th grade is doing their PBL. And I will let you know. We'll both be watching the clock for our time, and I will not shorten your lunch, because if I shorten yours, I shorten mine, right? I get the same amount of 20 minutes that you do. Questions up here. I had people in working this morning. Questions as I'm looking at yours. I can do 21. Any others? 36? Yeah, a little ugly, isn't it? So I write down number 21, and I have 4. 4 is to what power if there's no exponent? 1. A is to the first, right? B is to the 0. I am not going to, in simplest form, keep that 4 to the 1, but I know that that's 4 times A times B to the 0 is 1, and I am done. 4A is my answer. Because it's 4A times 1, which is 4A. Okay? Any other ones before 36? I don't want any decimals for these, right? I shouldn't have seen any decimals. I should have seen fractions, not decimals, in simplest form. Which one?
Like number 19, how's the decimal on it?
Oh, that one, yeah. And I don't even like how they did that. Because really, mathematically, we do not like to see one decimal in a fraction. We've talked about that. But this is what they were looking at. And then when they squared that, what did you get, Caitlin?
1 over 2.25.
2.25, yeah. And did they leave this as the answer in the back? Or did they put... Oh, yeah. Because so, when you look at this, we can't have this decimal. So when you look at this and you get that answer, if we're going to move the decimal over 2 places, right, that's like multiplying by 100. So you would have had 100 over 225. And 100 over 225 simplifies to... That's how they got that answer, right? We're going to say that 25 can go into both of those, right? 25 goes into 100 4 times. 25 goes into 225. How many quarters would you have? 9. That's how they got that answer. So yeah, can't have a fraction in there, okay? So if you see one of those. All right, so let's look at 36. In 36, as you're looking at that question, it first tells us that we have the 7, and we have this 7 is just to the what power? 1. So we don't have to move that 7 at all. That 7 stays where it's at. I noticed that down here I have 2 to the negative 1. I need to make that a positive exponent, so I'm going to move that to my numerator, and it is now 2 to the first. I really don't need that first there, but I do need the 7 times 2. M to the second was positive. It stays in the denominator. What am I doing with the t, Addison? To the negative 5.
Moving it down.
Moving it down. Does it matter if I put it before the m or behind the m? Does it matter? Not at all. So wherever you want to put it, and it's t to the 5th. And I can't leave my answer like this. So no, in the numerator, I'm going to multiply those and get 7 times 2, which gives me 14. And again, like I said, I don't care what order you put these in when you look at them in the back. Sam?
Like on the top when you have 5 to the 0, you get that it's 1, but why does it disappear?
So the s to the 0? You mean? So if I take 7 times 2 times 1, I mean, because I could write s to the 0 as 1, right? When I take 1 times anything, I just get what I started with, right? So even up here, when I look at this problem and I have 1 over 2 to the 0, that's simply just 1. So here, when I do this one, that's just taking this k to the negative 4 times 1, which is still going to give me k to the negative 4, and now I rewrite it with a positive exponent. Okay? 1 times that, because this would have been like 1 times that, okay? All right, make sure you have your name on your paper. At this point in the year, those of you know who you are, you kind of don't put that on. It goes in my recycle. So let's go to your notes. pass those. We're going to pass it to this aisle coming down here. You guys are going to pass yours over there. So Avery and Kate, and you guys are going to pass yours this way. And myself or Mr. Layden will pick those up. Notes. Thank you. And we can just keep those all together.
Okay.
All right, so we're now going to go to the multiplying powers. And when we multiply our exponents, some of you might remember the rule from last year when we multiply powers. Keeping in mind that this, that the rule is like if I have m to the fourth, that means 4 m's and 2 m's, and if I multiply them together, what do you think I'm going to have? M to the 6th. You guys remember what we're doing with our exponents when we multiply? Anyone remember from last year? You guys did this, you were adding them. So here you can think of this as -1 plus 3, which really gives us y to the 2nd, because we're adding -1 plus 2. Here you were adding the 4 plus 2. So the pattern when we multiply, you guys did see this last year, when we multiply powers. So, and the key thing is, if you have the same base, so if the base is the same, this only works when you have the same base. When the base is the same and you multiply powers, you will be adding their exponents. Now, in our Math 8, when we do this, we have them justify why this actually works, right? So of justifying how this actually works would mean, maybe I go up here and I show this. So my justify of this, so on our tests in Math 8, I asked them to justify, why do you know this? And they would have shown me something like this. They would show me that m to the 4th means that I have how many m's? 4. And that m to the 2nd, so times my m to the 2nd, means I have 2 more, which is a total of m to the 6th. And that would just be the justification of it. That's why it works. That's why anytime I have these, that it works. And if you had to justify this one, what would you do for y to the -1 that we know from today? We'd rewrite that as what? If I was going to justify 1 over y times y to the 3rd is this, right? Well, what's y divided by y? Ava. Yeah, it's 1. So how many y's are you left with? We're left with, this would be your justification. Does that make sense? Why the rules work. So this is kind of why these rules are that you had last year that you worked on or should have worked on. We get more complicated right away. You're going to see variables, numbers. You're going to soon see fractional exponents. So please try these. Leave your answer as a power. What does that mean, a power? That means I want a base and an exponent. Okay? First one, Sam, I should have 8 to the 9. Next one, I should be looking at 0.5. AJ to the, let's go negative first. -11. But I don't want to leave it negative, Lauren. How would I rewrite it?
-0.5 to the 11.
What does a negative exponent tell us? To make the number negative or do something else? What is that other thing else? It has an R word in it. Or you reciprocal. So help me out then. What could I do if I have 0.5 to the -11? I could rewrite it as 1 over. Do I want the 11 down here?
0.5.
All right. 0.5 to the 11. Okay. We're going to leave it like that because it says as a power. So I actually would have even let you leave it like this, but we really like positive exponents. The next one is you're looking at it, Avery. You ready? 9 to the 9 to the 5th. Right? -3 plus 2 is -1. -1 plus 6 is 5. So this rule is simply telling us that we are adding these together, -3 plus the 2 plus the 6, okay? Now we add in numbers with it. Those are our number coefficients. So we're going to just reorganize the problem. Do you have to reorganize it? No. But I think sometimes that helps. So I want you to think that this is 5, and then we're going to put our coefficient 3. We are then going to put x to the 4th times x to the 9th times x. X to what exponent if there's nothing here? 1. All right. So if we are going to take 5 times 3 gives us 15. Avery, x to the what power? 14. Sorry, I keep picking on you. I'll move it around. Let's try the next one as we're doing. Ryan, how are we going to rewrite it first? -4 times what?
7
Mm-hmm.
times 2.
Times 2. Do you think it's easier to go -4 times 7 and then take it times 2, or -4 times 2 and then 7? In your head, if you're doing it, no calculators. Which one would you do first? And everyone has their own preference. It doesn't matter, right? It really doesn't matter which one you do. So if we are multiplying, what are you looking at, Bryce?
Well, like with all 3 numbers.
Yep, all 3 of them. Disconnected. What do you get? So do you think 8 times 7 is easier than, right? Because we could do this, right? 4 times 2 is -8. 8 times 7 is? -56. If we're looking at it, -56. All right. And then, Georgia, we're going to have we're going to put our c's next, right? So we have c to the 3rd and c to the -2. What are we going to end up with c?
C.
Just c. We don't have to put the 1. And then we have this d to the 2nd, right? There's only one d to the 2nd. So usually alphabetic order, but it doesn't have to be. Again, you could have had d to the 2nd c, but they usually go alphabet. Try that last one. It's nice, you only have the one number, so it should be 12. Each person, the map testing is different because it looks at your goal from last year and what you got and how you did this year. Hang on, let's do this first. So if I am looking at that, Kylie, what'd you have? J to the 3rd and k to the -2. And so now with positive exponents, I'm going to rewrite it, Reese, and I'm going to have 12 times wait. We already simplified it to j to the 3rd. So from this answer right here, why do I want to change it more? Because I have a what? Yeah, I don't want negative. So we're still keeping the j to the 3. What am I doing? Does it help if I put this like this over 1? What power? No longer -2 positive, okay? So as you are looking at that. All right. The fractional exponents. You want to take this?
Try. Okay. So it says exponents can be expressed as fractions. So instead of having like e, like we had, e to the 5th power or something like that, or 10 to the 5th power, we could have a variable to the power of a fraction. So recall that 3 to the 2nd power means 3 times 3, which is 9. That's what they have here. And you can write the same expression using rational exponents. Just ring a bell.
So this is a little different than you guys have seen before, okay? And this 1/2 is really just telling us to take this 1/2 is just telling us to rewrite it this way. Where if I have 1 over any number, I'm trying to take, in this case, the 2nd root of this whole thing. And this whole thing, what I think of it, is this whole thing is to the first power. So when they give me this 9 to the 1/2, it really means take, so put this kind of right behind here. This means take the, and we usually don't put a 2 up here for square root, but it really means take the square root of 9. And the square root of 9 is 3. Okay? This is kind of hard to understand. I'll probably let you take the next class on this one.
Yeah.
I'll go through, talk about this just a little. So when I write this, I want you to put behind here, we're going to do another one like this. I want you to put 27, put this in your notes, 27 to the 1/3. What does that mean using a radical? It means what root? What number should I put out here? What root am I talking about? What's in my denominator? 3. And I'm going to take the 3rd root of 27. What is the 3rd root of 27? What number times itself 3 times gives us 27? 3, right? 3 times 3 times 3. You're doing it 3 times, okay? So this one says simplify 16 to the 1/4. Here is my hint. Always think about it as what number multiplied times itself 4 times is 16. You're trying to say the 4th root. That's what this means. The 4th root of 16. That's what that fraction means. What number times itself 4 times gives us 16? Well, it can't be 4, right? Because you do 4 only twice. It needs to be something that we do 4 times. 4 times should be 2. 16 to the 1/4 should be 2, as you are looking at that. Here's what I want you to write down the logos, and it's not in our, it's kind of in your textbook in this section, but to me, this is like really, really key, and I have this in my notes each year to make sure that I talk about with students is that I have A to the N over M. Now, all of our N's were 1 so far. They don't stay that way. It means this. The root, the mth root of A, and then it's like this whole thing is to the nth power. And you're going to see that in the next problem on the next page down in your notes where they ask us to simplify. So, I think it's easier for most students to write it this way because they can think of, oh yeah, find the cube root or take it times itself twice or 3 times. And just know, this is not the easiest stuff. So let's rewrite. 64, using what we just wrote in our notes. What number goes out right out here? Be what root? The 2nd. Do we have to write the 2nd in there? No. 64, and then we're taking this whole thing to the what power? 3rd. Well, what is the square root of 64? 8. And now notice how many 8s they have. They have it to the 3rd power. And our answer is 512.
Where did the 3 come from?
Where did the 3 come from? Right here. Did you have this down in your notes that I asked you to write in? That I know sometimes you always forget to write some of the things I say. You do? Okay, good. So, all right. So let's try the 81. Let's do that one kind of together. Let's write it as our root first. So we're going to put what root? 4th. We're taking 81, right? Try the next one. Tell me the root. You should be able, hopefully you guys remember, and usually they're pretty small numbers, right? 2, 3, 4, 5. I don't think there's anything bigger than 5 that we're looking at here. So the square root of 81 is 9, which means the 4th root should be 3. How do you check it on your calculator? 3 to the 4th power. 3 to the 4th equals 81, and it checks. This next one, cube root, Noah, of what? 27 equals 3. Lauren, how do I write the next one? Square root of 64. Addison, what is the square root of 64? 8. And again, you don't have to put the 2 in there. Mathematically, that's like one of those understood things. If you don't have a 2 there, then it means this. So our last one, Kylie, how am I going to rewrite it?
Fourth root and 16.
And then we're going to take this whole thing to the third. What is this equal to? 2. And now we have 2 to the third. Okay? So that's how we're getting that answer of 8. In the book, they just kind of go, oh, here it is. You just see this 1/4 and this 1/3 and this, and they don't really, that's where that comes from, of breaking it apart that way. Okay? And this is a little tougher. So look how nice, look at the level of fun we go to right away. We can't keep it simple too long, right? So notice that the first thing they do in this problem is they rewrite and they regroup things. They put all the number coefficients together by a commutative property of multiplication. We then put the like variables together. We put the A's together and we put the B's. We don't want to do what we were just doing. We want to use our rule of exponents when we multiply. What are we doing with their exponents? We're adding them. 2/3 plus 1/3 gives us 3/3, right? They just put it as a 1 down here. 1/4 plus 1/2, well, when you add those exponents, remember, if you're going to go with 1/4, you have to have 1/4 plus 2/4. You cannot add fractions unless they have the same denominator, okay? So that's how they got b to the 3/4, and then they multiplied the 30 out in front. So when you are looking at these, it says when we want to think about this, we want to simplify adding exponents, bases have to be the same. So we're not combining our a's and b's together. So we're going to do a little practice. I want you to start with these, and as you are looking at them, I'm going to have you...
You're avoiding eye contact. Okay, what do you have for the first one? What did you group together? Yep, so we put our coefficients together, that's good. I agree with that. And then all we have left is our c's, right? So we have times c to the 3/5 times c to the 1/5. So when you add exponents, we see we have same bases here, same bases here. How did you simplify after this? Yep, so we have 2 times 2 is 4, and then we add our 3/5 and 1/5, so we have c to the 4/5. Everyone get that? Okay. Is anyone ready for the second one? No?
b to the what? We're going to start with what? 2/3 and 4/9. What's my common denominator? 9. So I need to change from 2/3, I need it to be 9ths, right? How many 9ths am I talking about? 6/9 plus 4/9. I'm going to regroup my c's, and I had 2/5 times c to the 9/10. Again, c, and I'm adding 2/5, I need to go with 4/10, right? And 9/10. Georgia, what are you getting?
For B,
Mm-hmm.
it would be B to
Mm-hmm. You're not going to change them to mixed numbers. Okay, we leave it as improper. And C, Ryan, to the
15.
done. I know, you're wondering, it's like past our normal lunchtime. It's like your stomachs are growling. If you haven't done this next one, do this. What am I looking at for that one? Daniel, did you get something?
No.
What are we doing with the exponents?
Adam.
Mm-hmm. So 1/3 plus 4/3, right? Gives us, there you go. Do you have to write this down? No, I know that you're adding them. This next one, you're grouping your 3's together, right? And your 7's. That's 3 squared times 7 squared, right? You got 3 squared, you got 7 squared. We got J, 2/3 and 1/6. Can I right away make this 4/6? and j to the 1/6. I know I'm adding, I'm going to have a common denominator, right? M to the 1/4, m to the 6/4. We're going to go to lunch. Get this, 3 squared times 7 squared. So 9 times 49 should give us, you probably use your calculator for that, 441. So now when we look at our powers of j, Kaylin, what are we going to have? J to the, what power? What are we doing with our exponents?
5, 6.
Yep, j to the 5/6. So we have 441, j to the 5/6, and Lauren, m to the
7/4.
m to the 7/4. And you're going to leave it like that, okay, as you are doing your homework when you're looking at those. So it's mostly working with the addition, with when the bases are the same as adding those exponents. And tomorrow or Monday when you come in, we will be looking at doing a little more with the multiplication properties, but it's where we do power to a power. So in your workbook, F2, it is just this one side of the worksheet that you are looking at. That's all you are looking at for Monday. So as you look at this, anytime you see where it says simplify, and it says leave your answer as a power, what that means is we want the base to an exponent. I still don't want any negative exponents. So let's just look at number 12. They're both in the denominator. And since they're both in the denominator, Bryce, the same base, we're adding them. What do you end up with? Just 8. If it would have been a negative 1, you'd move it up, but since this is a positive 1, 1 over a, and this is your answer, and you are done. Okay? So you have the fractional ones. My hint is when you take a look at that fractional one, like in 13, it's telling us 8 to the 1/3. Think about it as the cube root of 8. I think that will help you on those ones that are kind of like that as you are working on that 13 through 15 ones. And those are really the only ones with the fractional ones. And then 19 is a challenge one that you should be looking at. It's not